Today we are going to do functions in Python. So, what are functions? Well, functions in any program are essentially subprograms that take in some input and often return a value. So let's say I have a function whose sole job is to add C to the input. And let's say my input is some A. So every time that I send in A, my output is A plus C. Similarly, let's say I add something else. Whatever I send inside that function, it's added by C and sent out. So a function is a subprogram that takes in an input and often returns a value. Why do I say often? Because there are functions which do not necessarily return a value, as we will see shortly. Okay, what are the different types of functions that we have? Well, you might have already seen some of them. Functions can be classified into three types. The first being user-defined functions, which we are going to do today. The second being built-in functions. And lastly, functions in modules. What do I mean by built-in functions? Built-in functions are those which are available to be used at any time in the program. So some examples would be your print function, your len function. These can be used at any time in the program. They are built into it. Let's talk about functions in modules. These functions exist somewhere, but to use them, you need to tell the computer, hey, that I need you to bring this into my program and from that execute it. So let's say you wanted to use CSV functions. To use CSV functions, you would need to import CSV into your program, following which you could use CSV functions. Okay, so these exist, we can use them at any time. We can call these and then use it. What about user-defined functions? How can we create functions? Well, to create functions in Python, we follow a particular syntax. Now, the syntax for that is def function name parenthesis colon code of the function and then the function call statement. Let's break this down. Def is a keyword. It tells the computer that whatever follows it is the declaration of a function. We are creating a new function and this is where it starts. Colon is used to indicate what comes now is the body of the function. So this is the function body. This f name is the name of this function. It could be anything. It could be cat, dog, doesn't matter. These parentheses normally contain parameters. What are parameters? Well, they are the values that are being sent into this program. We'll talk more about them. For now, let's see how we can create functions. Now, in case I do not want to give any parameters to this function, I'll leave it blank. Okay. What is this? This is my function call statement. When I run the program, wherever the compiler or interpreter encounters a function call statement, that then it goes to this function header and then executes the contents, the function body essentially. So together, this whole thing is called a function header. So a function header is the part of the program that starts with def, ends with a colon, and establishes the function name and the parameters. Okay. Now we have some types of functions which return values as we saw in the example before. If a function returns a value, it normally contains a return statement followed by the value it is returning. This is called the return statement. Okay, let's look at an example. Let's create a function to add two numbers together. Let's say I want a function that adds 5 and 15 and prints the output. So let me create a function def add 2, a is equal to 5, b is equal to 15, c is equal to 5 plus 15, or actually that's redundant. Let's write c is equal to a plus b, print c, and then I call my function add 2. But let's say I do not know what the numbers are. Let's say I want the numbers to be accepted from the user. Well, the way I would do that is I would go to these parentheses there and mention parameters, which are essentially the values being sent into the values being received by this function. So let me write a comma b, and then in my function write c is equal to a plus b, print c. And then I'll go back to my main function and say val1 is equal to int input enter a number, and val2 is equal to int input enter a number, and then I call my function add 2. But how do I send them these values? Well, to send them these values, we write the names of the values we want to send in the parenthesis where the function call statement is. So I'll write val1 comma val2. So what happens here is the value of val1 is sent to A, and the value of val2 is sent to B. So that's how we would send values to functions. Let's say now that I have some values which are being which I have, and I don't want to print them. I want to save them to a different variable. Well, the way I would do that is I have my function header here. I have c is equal to a plus b. Now I'll say return c. And in my main part of the function, I mean of the program, I'll write add to a, let's say I'm sending 5 comma 10. And now I'll add one tiny detail here. Z is equal to add to 5 comma 10. So what happens now is the value of 5 is sent to A, the value of 10 is sent to B, and C adds them together and returns it. When it is returned, what happens is this value of C comes here, replaces this entire function. And so now what I'm essentially left with is Z is equal to C. So the value of C goes to Z. Okay. This was uh, this was an introduction to um, our chapter, and now let's move on. Let's move on. So we saw that we created a function heading, we did some coding, and then we call the function, some value was sent somewhere. How does that all work? The way it works is by something called flow of execution. Flow of execution is essentially the order in which a program is executed. So in Python, there are certain rules of flow of execution. The first one being it begins at the top of the program, which I think we all would have guessed anyways, right? Programs are executed from the top. Okay. So it begins from the top of the program. What's the second rule? The second rules is all comments are ignored. Well, yes, we know that when we write a comment, it's not executed, but yes, that is a part of the rules of the flow of execution. Okay, what's the third rule? When a function definition is encountered, so let's say I have def um, f add, let's say just def add 2 again, a comma b, some code, blah blah blah, and then add 2, 5, comma 10, c is equal to. So let's look at this example. I'm going to try and explain two rules of flow of execution with one. Okay. So whenever Python encounters a function header, what it does is it checks if this function header is valid. So if the entire function header is valid. If it is valid, it will move directly from here to the line outside the function. It does not look at the function at all. Okay. Now what happens when it starts executing and then it encounters a function call statement? When it encounters a function call statement, it jumps to the header. Then it will jump to the next line in the code, the next, the next, the next, and so on. Let's say it's completed execution. Let's remember the previous example of how we had uh, we return the value of C to our caller function. So what happens is if there was a return statement here and some value is being returned, in that case, the control jumps from the return statement to the caller statement and it replaces that caller statement with the return value. So whatever value was being returned is sent here. And then from here it starts proceeding to the regular program again. But if there is no return statement, if let's say that this return statement is not there, then it jumps to the line after the function call statement. And similarly, from this, you can also notice that when we had a return statement, it immediately jumped to the caller part. So that means that anything that is after the return statement is non-executable. Any code that you write after the return statement is non-executable and is not read by Python. Okay, these were a lot of rules, but it is important to have an idea of what is going on in the background when you execute a program. Okay, let's talk about arguments and parameters. So what are arguments and what are parameters? Well, let's say I have a function definition def add 3 a comma b comma c and some code, and then I have my function call statement add 3 1 comma 2 comma 3. So parameters are essentially the values being received, whereas arguments are the values being sent. Right? So 1, 2, and 3 are the values which are being sent to A, B, C, which are receiving them, which are the parameters. Okay. Now we have different types of arguments, or rather parameters. Now the three different types of parameters are: number one, positional parameters or arguments. Well, um, normally they are used interchangeably. For now, I'm going to call it positional arguments because, as you'll see, these are the values that we are sending into the function. So let's call them arguments. So positional arguments, default arguments, and lastly, keyword arguments. What do I mean by each of them? Let's take a look at them one by one. So positional arguments basically ensure that the number and the order of the arguments in the function call statement match those in the function header. So if I have a function header with ABC as the parameters, and I have my function call statement with 1, 2, and 3, it ensures that the number of values being sent and the type of values being sent are um, permitted. Let's say I keep only 1 and 2 and I'm trying to send it to ABC. Well, this is not going to work because the rule of positional arguments say that the number and type of arguments must match uh, what is given in the function header. Okay. Then what are default arguments? Default arguments are used when we want to provide a default value to the parameters. What this does is, in case one is not provided in the function call statement, but I have given that in the function header, the value from function header is used. So let's say I have a comma b comma c is equal to 10. And if I give only 1 comma 2, what happens is 1 is sent to A, 2 is sent to B, and it comes here. Nothing is being sent to C. So the value of C is taken as 10. Now, if I was to give some other value, let's say 8, then it will take this new value and not consider the default one. All right. Let's say I want to give default values to A instead of C. Can I write this as A is equal to 10, comma B, comma C? Well, no. In Python, to provide default arguments, the rule is that all arguments appearing to the right should have default arguments. So if I wanted to give default arguments to A, I would need to give to B and C. Okay. And lastly, let's look at keyword arguments. Keyword arguments essentially say in my function header, sorry, function call, if I write, let's say I want to call my function add2. So if I write add2, b is equal to 10, comma a is equal to 5, this is valid. It doesn't matter the order in which I write as long as I'm writing for all that are needed. All right. Let's move on. Let's say I want to use multiple types of arguments together. Well, that is allowed. The only rules is that positional arguments are always before keyword arguments. So the values which I want from the user should be before my keyword values. And the second rule is that values for one thing cannot be given multiple times. So I cannot write b is equal to 10 and then write b is equal to 5. This is not permitted. Okay. So a lot of information, a lot of um, complicated theory. Let's move on to something simpler. In fact, let's talk about something that is really important to our function programs. Let's talk about the return statement. What is the return statement? Well, the return statement's job is to return a value essentially. Seems pretty straightforward. But functions are also divided into two types depending on which it is in terms of the return statement. What do I mean? Well, if a function has a return statement, it is called a non-void function. Well, what's the definition of a non-void function? It's a function which returns some type of value, or it's a function which returns uh, a result in terms of a value, either one. And the second type is if a function does not have a return value, then it's called a void function. So void functions are essentially functions which perform some action but do not return value. So perform action, do not return value, return value. Okay. Can a function have a return statement and still be a void function? Yes. Let's take an example. Let's say I have some function and I have some code here, and I just write return and leave it blank. Since I'm technically not returning any value, this is counted as a return function. But if I was to write a is equal to and then the function call statement, what would happen is a would be assigned the special literal none, which indicates the absence of a value. So this is a valid example of a void function. Whereas a non-void function, on the other hand, always returns some value. It could be return 5, it could be return a, it could be return a plus 5 divided by 100. It does not matter. Return accepts strings, booleans, expressions. All of that is valid. They are all perfectly correct examples of non-void functions. Okay, so we saw that um, void functions could have a return statement and the value that they return is none, but non-void statements can also return any kind of value. Okay. What if I want to return not one, not two, not three, let's say five values in my return statement? That is also valid. Return statement allows you to write return value 1, comma value 2, comma value 3, comma value 4, comma so on and so forth, as many values as you wish to return. They are all allowed. But that would make you wonder, how does the computer receive these values if I have such a huge number of values? So let's take a case. Let's say I have a function def squared x, y. And let's just take another example to make things clear, x, y, z. And what I essentially will do here is I'll write return x star x, comma y star y, comma z star z. So what happens here is this function is basically squaring the number which I have and returning it. And let's say I want to save it in some variable t is equal to squared of 1, 2, and 3. And then I say print t. So what do you think the value of t would be? I'm getting three values in my return statement. So how would that look like? In this case, it would be saved as a tuple. So when you print it, the value will be 1, 4, 9 in tuple form. On the other hand, let's say I want to save them all to different variables. How would I do that? Well, for that, I would need to know the number of values that are being returned. In this case, I know the number of values being returned. So I'll write P comma V comma L is equal to squared 1 to 3. So the value of once this function is completed and I get 1, 2, 1, 4, and 9, the value of 1 is saved in T, the value of 4 is saved in V, and the value of 9 is saved in L. And then I can perform whatever calculations I wish to do with them. So that's how we can return multiple values in two different types. Now, let me give to you an example. Let's say I have a bank with three lockers. Now, I have a key which opens my locker, and then there's this bank manager who can open any locker he wants. My key is valid only for my locker. If I try to open this locker or this locker, it won't function. Whereas the bank manager, he could walk in and open any of the three lockers. Similarly, when we have programs, there is something called scope of variables, which dictates where a particular variable is valid. So let's say I have my program and I declare some variable a is equal to 5. And then I have a function def uh, p which has a variable b is equal to 10. And now I say print a, print b. Well, this will not work because let's thinking of our example again, b in this case is declared in this function p, whereas a is declared as part of the main program. So A is the bank manager, whereas B is me. I can only work within my function, whereas A can work anywhere in the program. So that is essentially the scope of a variable. It is so scope of the variable can be defined as the part of a program where a name is legal and accessible. That is called the scope of a program. Now, let's look at the way Python evaluates this scope. Let's say I have two variables named A, which are in my program. How does Python know what is to be executed when? Well, Python follows a rule called LEGB rule, where L stands for local, E stands for enclosing, G stands for global, and B stands for built-in. And the way Python executes this is it checks this order with L being the first to be checked and and B being the last to be checked. And the way it does this is, let's consider an example program. Let's say I have a program where I say A is equal to outside, and then I have def um, testa test ABC, and here I have A is equal to 5, and I say print A, print A. So what happens here is Python, in the flow of execution, Python comes here, it sees A is equal to outside, okay. It comes here, function is valid, okay. It comes here directly then and says print A. Now for this A, the local environment is this, the whole program. So then it knows that the value for this is only outside. Let's say now that I call my function somewhere test ABC print A. What happens now is once this function is called, this print statement first checks its local environment. And yes, within the local environment of this function, we have an A. And thus it prints that. But let's say I didn't have an A over here. Well, Python will come, it will check the local environment, but there is no A over here. So then it will check the enclosing environment. If there were multiple nested functions, it would check that. But there's no multiple nested functions here. So then what Python does is it goes to the global environment and it finds A. So in this case, when I say print A, this A will print outside, and out when we leave the function, this A will also print outside. So that's how the evaluating of these functions work. But let's say that I want to change the value of A. So let me create a function def part2 and say A is equal to A plus 5 and print A, and I call that function here. And at the start of the program, I declare A is equal to 1. What happens now is Python would come here, it would try to execute this, but there's a slight complication that it encounters. Inside this function, nowhere have I declared A. Therefore, when I'm trying to add some value to A, there is an error because you cannot add something to a variable which does not exist. Let's say I want to tell Python use the value of A which I have given outside. So the way I would do it is similar to the way we import new modules into Python. I would say global A representing the global variable A, and then say A is equal to A plus 1, print A, and then call the part2 function, which would now work perfectly. So the way we get globally declared variables into our program is by using the global keyword. Why is this important? Well, let us consider our original example here where we say A is equal to outside def test ABC, A is equal to 5, print A, print A. What happens here is this print statement will print 5 because when it does not find a value of because it finds the value of A in its local environment. But if I wanted to make changes to the A which is globally present for all to access, I would write global A at the start of this program, and I apologize for this messiness, but then the A is equal to 5 which I write here will change the value of the A present here. So what happens now is when I say print A, I get 5, and when I say print A again, I get 5 once again. But if I try to write, let's say, if I try to write A is equal to 10, then global A and then A is equal to 5. So essentially, if I try to create a local variable with the same name of the global variable which I'm trying to import, then Python raises an error as that is not allowed. And I know this was a lot of theory and a lot of um, memorizing to do, but this is a very important topic in Python. So this was part one of functions. We have a small bit of portion left in that, which I will complete in the next video.